Unleashing the power of AWS Lambda. Features, benefits, and practical examples. In today's digital era, scalability, flexibility, and cost-effectiveness are paramount for businesses to thrive. AWS Lambda, a serverless compute service provided by Amazon Web Services, AWS, has emerged as a game-changer in the world of cloud computing. In this comprehensive video, we will delve deep into AWS Lambda's features, explore its numerous benefits, and provide practical examples showcasing how it can revolutionize your application development and infrastructure management. What is AWS Lambda? AWS Lambda is a serverless compute service that lets you run your code without managing servers. It automatically scales your application in response to incoming traffic and executes code in response to defined events, such as HTTP requests, changes to data in an Amazon S3 bucket, or updates to an Amazon DynamoDB table. You only pay for the compute time you consume, making it a cost-efficient solution for businesses of all sizes. Key features of AWS Lambda. Event-driven architecture. AWS Lambda operates on an event-driven architecture, where functions are executed in response to specific events. These events can originate from various sources, such as AWS services, custom applications, or external systems. The event-driven model enables you to build applications that respond instantly to changes in the environment, making it highly reactive and reducing the need for continuous polling or checking for updates. The event sources supported by AWS Lambda include but are not limited to API Gateway. Lambda functions can be invoked in response to incoming HTTP requests through the API Gateway, allowing you to build serverless APIs quickly. Amazon S3. Lambda can process events when objects are created, modified, or deleted from an S3 bucket, making it an excellent choice for handling data uploads or image processing tasks. Amazon DynamoDB. With DynamoDB streams, you can trigger Lambda functions when changes occur to your NoSQL database, enabling real-time data processing and analysis. Amazon Kinesis. Lambda can process data streams from Amazon Kinesis, which is ideal for applications that require real-time data ingestion and processing. Amazon SNS. Lambda functions can subscribe to Amazon's Simple Notification Service, SNS, topics and perform custom actions when notifications are published. Amazon Cognito. Lambda can be used to customize authentication flows and respond to user sign-ups and logins. Supported languages. AWS Lambda supports multiple programming languages, providing developers with the flexibility to work with the language they are most proficient in. As of our latest knowledge, the supported languages are Python, a powerful and easy-to-read language, Python is widely used for web development, automation, data analysis, and more. Node.js. Built on Chrome's V8 JavaScript engine, Node.js is well suited for server-side applications, particularly those requiring real-time interactions. Java. A popular language for enterprise applications, Java provides a robust and object-oriented programming environment. C#, .NET Core. C# is commonly used for Windows applications, and its compatibility with Lambda allows developers to leverage their existing skills. Golang is known for its simplicity, efficiency, and strong support for concurrent programming, making it suitable for distributed systems. Ruby, a concise and elegant language, Ruby is often used for web development and scripting. The language options enable developers to choose the most appropriate language for their use case and work within their comfort zone. Auto-scaling and high availability. AWS Lambda takes care of the infrastructure provisioning and scales your functions automatically in response to incoming traffic. It ensures that there are enough concurrent executions available to handle the incoming events. If your application experiences a sudden surge in traffic, Lambda automatically allocates additional resources to meet the demand, and when the traffic subsides, it scales down accordingly. This auto-scaling feature helps in cost optimization, as you only pay for the compute resources you consume during the actual execution time. Moreover, Lambda automatically replicates your functions across multiple availability zones, AZs, within a region to ensure high availability. If one AZ experiences a service disruption, Lambda will route requests to available AZs, providing fault tolerance and increased resilience for your application. Integrated security. Security is a top priority for any application, and AWS Lambda integrates seamlessly with AWS Identity and Access Management (IAM), enabling you to define fine-grained access controls for your Lambda functions. IAM allows you to assign roles and permissions to your functions, ensuring they can only access the resources they require and nothing more. This principle of least privilege enhances the overall security posture of your application. Additionally, Lambda functions running inside a VPC can access resources within the private network securely, without exposing them directly to the public Internet. This capability is particularly beneficial when dealing with sensitive data or integrating with on-premises systems. Built-in monitoring and logging. AWS Lambda offers robust monitoring and logging capabilities through Amazon CloudWatch. CloudWatch allows you to collect and track various metrics related to your Lambda functions, such as the number of invocations, error rates, and execution duration. You can set up alarms to receive notifications when specific thresholds are breached, enabling proactive response to issues. Lambda also integrates with AWS X-Ray, which provides distributed tracing to help you analyze the performance of your serverless applications and identify bottlenecks or latency issues. Furthermore, Lambda automatically captures logs, including any output generated during the execution of your functions. You can view and analyze these logs through the AWS Management Console or export them to other monitoring tools for centralized log analysis. VPC support. Lambda functions can be deployed within your virtual private cloud, VPC, providing a secure and private network environment. When a Lambda function is configured to run within a VPC, it can access resources like databases, cache clusters, or on-premises systems hosted within that VPC. Using Lambda within a VPC extends the capabilities of serverless computing to applications that require direct access to private resources or must comply with strict security and network isolation requirements. Benefits of AWS Lambda. Cost savings. One of the most significant advantages of AWS Lambda is its cost-effectiveness. With traditional server-based architectures, you need to provision and pay for compute resources even when your application is idle. In contrast, Lambda follows a pay-as-you-go model, where you are only billed for the compute time your functions actually consume. This means you don't pay for idle resources, resulting in significant cost savings, especially for applications with varying or sporadic traffic patterns. Furthermore, Lambda's automatic scaling ensures that your application can handle any level of incoming requests without the need for manual adjustments. This dynamic scaling capability allows you to respond efficiently to fluctuations in user demand while optimizing costs during periods of low activity. Improved scalability. Scalability is a critical factor for modern applications, especially in the era of unpredictable traffic spikes and growing user bases. AWS Lambda's auto-scaling feature ensures that your functions can handle any number of concurrent requests automatically. As the number of incoming events increases, Lambda automatically provisions additional compute resources to accommodate the workload. This dynamic scaling not only ensures high performance during peak times but also eliminates the need for capacity planning and resource management. Your application can seamlessly handle any scale of traffic without manual intervention, providing a smooth and responsive user experience. Faster time to market. AWS Lambda accelerates the development cycle by removing the burden of infrastructure management. With serverless computing, developers can focus solely on writing code and building features rather than dealing with server provisioning, scaling configurations, or operating system updates. The reduced operational overhead and quick deployment times offered by Lambda enable teams to release new features and updates faster. This agility is invaluable in competitive markets, allowing businesses to respond quickly to customer feedback, industry trends, and emerging opportunities, ultimately leading to a faster time to market for products and services. Reduced operational overhead. Traditional server-based architectures require significant operational efforts, including managing servers, monitoring performance, applying security patches, and handling scaling challenges. AWS Lambda abstracts away these operational complexities, allowing developers to concentrate on their core application logic. By offloading the infrastructure management to AWS, you can significantly reduce your operational overhead. This enables your operations team to focus on higher-value tasks, such as optimizing application performance, enhancing security measures, and implementing best practices. Flexibility and vendor lock-in prevention. AWS Lambda offers a flexible environment that supports multiple programming languages, making it easier for developers to work with their preferred languages and frameworks. This flexibility enhances the productivity and creativity of development teams, enabling them to choose the best tools for their specific use cases. Moreover, AWS follows open standards, and its services are designed to be interoperable with other cloud providers. This means that, while leveraging AWS Lambda, you can maintain portability and prevent vendor lock-in. If you ever decide to switch cloud providers or adopt a multi-cloud strategy, you can do so without extensive code modifications, minimizing disruption to your applications. Easier application management and maintenance. AWS Lambda's serverless model simplifies application management and maintenance. As your application scales, Lambda automatically handles the provisioning of resources to match demand. This built-in management feature helps eliminate operational complexities, especially during times of unexpected spikes in traffic. Additionally, Lambda's integration with AWS services and event-driven architecture allows you to build applications as a collection of small, decoupled functions. This microservices-like approach makes it easier to maintain and update individual components without affecting the entire application, enhancing agility and maintainability. Practical examples of AWS Lambda. Image processing and resizing. Imagine you have a web application that allows users to upload images for their profiles or posts. With AWS Lambda, you can automate the process of image processing and resizing, ensuring that all uploaded images are appropriately optimized for display without overloading your servers. Here's how it works. Image upload. Users upload their images to an Amazon S3 bucket dedicated to storing user-generated content. Event trigger. AWS Lambda is configured to trigger automatically whenever a new image is uploaded to the S3 bucket. The Lambda function receives information about the uploaded image, such as its file name and location. Image processing. The Lambda function executes the image processing code, which can use a library like Python's PIL, Python Imaging Library, or Node.js Sharp to resize the image to different dimensions, create thumbnails, or apply filters. Storage. The processed images are then saved to another S3 bucket or any other desired destination, making them ready for display on your application. By using AWS Lambda for image processing, you offload the compute-intensive task from your application servers and ensure a responsive user experience, even during periods of high image uploads. Real-time data processing. Consider a scenario where you have a system that collects streaming data from IoT devices, mobile applications, or social media. AWS Lambda can be instrumental in processing this real-time data efficiently and taking appropriate actions. Here's how it can be implemented. Data stream. Streaming data from sources like Amazon Kinesis is sent to an AWS Kinesis data stream. Lambda trigger. AWS Lambda is connected to the Kinesis data stream, and each time new data arrives, Lambda is triggered. Data processing. The Lambda function processes the incoming data, performing tasks like data enrichment, filtering, aggregations, or real-time analytics. Integration with other services. Based on the data's content, Lambda can take further actions, such as storing processed data in Amazon DynamoDB for long-term storage, sending alerts via Amazon SNS or email, or updating a real-time dashboard using Amazon API Gateway and WebSocket connections. By using AWS Lambda for real-time data processing, you can achieve near-instantaneous insights and take proactive actions based on the data flowing into your system. Chatbots and voice assistants. AWS Lambda is an excellent choice for building interactive chatbots and voice assistants. When combined with services like Amazon Lex for chatbots, or Amazon Polly for text-to-speech conversion, Lambda allows you to create intelligent conversational interfaces with minimal effort. Here's how it can be achieved. User interaction. Users interact with the chatbot or voice assistant through a web interface, messaging platform, or voice-enabled device. Intent recognition. The user's input is sent to Amazon Lex, which recognizes the intent behind the message and extracts relevant data. Lambda function trigger. Amazon Lex is configured to invoke an AWS Lambda function for each recognized intent. Custom logic and responses. The Lambda function processes the intent, executes custom business logic, and prepares the appropriate response. Response generation. The response, generated by the Lambda function, is sent back to the user through the appropriate communication channel. By leveraging AWS Lambda for chatbots and voice assistants, you can create natural and dynamic conversational experiences without the need for maintaining and scaling dedicated server resources. Scheduled tasks and cron jobs. AWS Lambda is also suitable for running scheduled tasks and cron jobs in a serverless manner. This approach eliminates the need to manage dedicated servers or containers for recurring tasks. Here's how you can set it up. Schedule definition. Using Amazon CloudWatch events, you define the schedule for executing the Lambda function. You can use cron expressions or simple fixed-rate schedules. Lambda execution. At the specified intervals, CloudWatch events trigger the associated Lambda function. Scheduled task. The Lambda function performs the predefined task, such as generating a daily report, cleaning up temporary files, or executing periodic database maintenance. Task completion. Once the task is completed, the Lambda function shuts down automatically, and you are only billed for the time the function was actively executing. By using AWS Lambda for scheduled tasks, you ensure that repetitive operations are executed reliably and efficiently without the need for maintaining server instances or configuring additional scheduling systems. In conclusion, AWS Lambda has emerged as a revolutionary serverless compute service, offering a plethora of features and benefits that empower businesses to build scalable, cost-effective, and flexible applications. Its event-driven architecture, support for multiple languages, and automatic scaling make it a perfect fit for various use cases. Whether you're a startup, an established enterprise, or an individual developer, AWS Lambda provides an excellent platform to unleash the true potential of your applications. By leveraging practical examples like image processing, real-time data processing, chatbots, and scheduled tasks, you can witness firsthand how Lambda simplifies application development, reduces operational overhead, and accelerates time to market. Embrace the power of AWS Lambda and take your cloud computing endeavors to new heights. Please subscribe to our posts at www.a2zofsoftwareengineering.blog. Follow our podcasts and videos available on YouTube, Spotify, and other popular platforms. Have a great reading, viewing, and listening experience.